Okay, now for part 3, we're going to show you how to find the inverse of a matrix. And I'm going to stick just to 2 by 2s because if it works for a 2 by 2, it's going to be the same thing for a 3 by 3, 4 by 4. And if I'm going to ask you to do one of these by hand, I'm just going to keep it to a 2 by 2. So make sure you understand these two techniques. So I am technically going to work with that same matrix, same two matrices we had before. 3, 1, 2, 1. I think that was matrix A. And we're going to try to find matrix B from the previous example. So we're going to pretend we don't know what it is. And what I'm going to do is I'm going to use that multiplication identity that I had, where if you multiply two inverse matrices, you get it equal to the identity matrix. So if they just give us a square matrix, call it 3, 1, what we're going to do is multiply a variable matrix. 4 different variables, A, B, C, D. We're going to multiply this together and set it equal to the entries that we have over here. What's going to happen is you're going to create a system of equations to solve. All right, so again, multiplying this together, row 1 times column 1 will have to equal row 1, column 1, this one right here. So 3 times A plus 1 times C has to equal that 1 right there. Next, we're going to do row 1, column 2. Row 1, column 2. And that has to equal row 1, column 2 in the identity matrix. So this is going to equal a 0. 3 times B plus 1 times D has to equal 0. Now we'll do second row, multiply to each column. Row 2 times column 1 has to equal the 0 here in row 2, column 1 entry. 2 times A plus 1 times C has to equal 0. And notice I'm lining these up because my A's match my C's. Now when I take row 2 times column 2, I'll have B and D's, and this has to equal row 2, column 2 entry. So 2 times B plus 1 times D has to equal 1. So I have two systems of equations that I'm now going to solve. And we're going to solve them both at the same time because we're going to do the elimination method. So here, 1C, 1C, 1D, 1D. Literally subtract the two equations. 3A minus 2A will give us 1A. 1C minus 1C cancels, 1 minus 0, 1. 3B minus 2B is B. The D's cancel, 0 minus 1, negative 1. You just solved for A and B. All right? So how do I find C and D? You plug A into one of these two equations. You plug B into one of these two equations. Well, in my back substitution, I'm going to use the same equation, the 2 on the bottom. 2A, okay, put 1 in for A, plus C equals 0. That's a 2 subtracted over C is negative 2. Put negative 1 in for B. 2 times negative 1 is negative 2. Add the 2 over to the 1. That makes a 3. So A, B, C, D, I've found the inverse matrix. It's 1, negative 1, negative 2, 3. Okay? So that's the multiplication method. That will be a valid technique that you can use on the test. The second one that you can use is the Gauss-Jordan elimination technique. So we build an augmented matrix. This is the matrix that was given right there. And you use the identity matrix on the right side of the augmented line. And you use the Gauss-Jordan method to make the left side become the identity matrix, and then the identity matrix on the right will turn into the inverse matrix that was on the left. All right, so let's get started. 3, 1, 1, 0, 2, 1, 0, 1. I need to make the 3 into a 1. Well, you could divide by 3, but I don't want to work with fractions, 1/3, 1/3. So look below the 3, there's a 2. Let's go 3 minus 2 and make that a 1 and replace the 3. So row 1 minus row 2 will be my new row 1. So 3 minus 2, 1. 1 minus 1, 0. 1 minus 0, 1. 0 minus 1, negative 1. Well, we're getting pretty lucky here. We've got the downhill diagonal of 1s. We've got a 0 here. All we need to do is turn this 2 into a 0. Hopefully we don't change this 1. So look to this 1, and we're going to multiply by the opposite of where we want the 0. So the opposite of 2 is negative 2. So negative 2 times the 1 in row 1, add it back to the row 2, and that's going to be our new row 2. So negative 2 times 1 is negative 2. Negative 2 times 0 is 0. Good, we're not changing it. Negative 2 times 1 is negative 2. Negative 2 times negative 1 is positive 2. Crunch the numbers. Here's the identity matrix on the left, and here is the inverse matrix on the right. And we're done. For 2x2 matrices, there are shortcuts if you probably do a Google search. If you do that shortcut, I won't give you credit for it because that shortcut only works for a 2x2 square matrix. If it's a 3x3 matrix, it will not work. All right? So these are the two by hand techniques that we will use to find the inverse of a matrix by hand. All right, so there's part 2.